Okay, so today we're going to start carbonyl compounds. Carbonyl compounds are defined by carbon double bond with oxygen. What this means is that this is obviously going to have sp2 hybridization because carbon is going to have 3 single bonds and 1 double bond. Okay. And that double bond, one of them is obviously the single bond and the other is this pi electrons. And just like the carbon-carbon double bond that we saw earlier, where there were pi electrons, which was a region of high negative charge, just like that, we are also going to see the same trend in carbonyl compounds. This region, this one, is a region of high negative charge. So there's a lot of negative charge moving around in the delocalized pi electrons. Okay, so that's the first idea. Now, how are different carbonyl compounds different from each other? So carbonyl compounds comprise of 4 main characteristics. There's the one with carbon double bond and R. This is what all carbonyl compounds have. They have a carbon and group on one side, a carbon with double bonded oxygen. And on this side, that is going to change. So if this one is H, we call them aldehyde. Okay. If this one is also an alkyl, we call them ketones. If this thing is OH, we call them carboxylic acid. And this you are already familiar with. And if this thing is O with an R, we call them ester. Now, these two follow a certain similar pattern in reactivity, but these two follow another similar pattern. So, ये दो further subgroups of carbonyl compounds, and they are based on the ester link that they have. So if C00 is available, then that thing will have slightly different properties than the C with just one oxygen. ठीक है? So carbonyl की जब हम बात करेंगे, जो हम reactions देखेंगे, we'll primarily deal with aldehyde and ketone, और उनके जो C00 वाले reactions हैं, we'll get to those a little later in the chapter. ठीक है? तो अभी के लिए जो हमने बात करनी है वो aldehyde और ketone की है. अब ये bond polar होती है, because oxygen is negative and carbon is going to have slightly positive character. Okay? And obviously there's negative charge moving around the pi electrons. So uski wajah se oxygen ki electronegativity is high. It attracts the electrons more, both the sigma and the pi. So this basically gives a slightly positive charge, a slight electron deficiency to the carbon. And this is the primary reason why carbonyls react the way they do. So दो बातें हैं इसके अंदर. Number one, there is pi electrons which are moving around a region of high negative charge, and second, there is going to be poles, dipoles. In fact, that oxygen and carbon bond is slightly, it is in fact polar. ठीक हो गया? अच्छा, अब इनके नाम कैसे हम रखेंगे? नाम बड़े सिंपल हैं. Aldehyde will have Al at the end of the name. Ketone will have O and E at the end of the name. Or carboxylic or ester तो हम जानते हैं. Okay. Now, the only difference is that in carboxylic, this is the main chain, and ester, this is the main chain, and this is considered a branch. Sorry. So if this is ethyl, that basically means it's coming from the alcohol and giving us, it will act as a branch. So अगर हम aldehydes का नाम लें, so first aldehyde would be sorry. So first aldehyde would be this one with just hydrogen on both sides. And this one is called methanol. Okay. Now you will notice that in the exam, what they do is they don't draw them like that. They use the Vesper theory and they draw them in 120 degrees. And that is what I would suggest you do, because it makes it easier to read these things, और उनको पढ़ना और use करना आसान हो जाता है. So always follow the Vesper when drawing them out.
Wait, so we have to draw it like with like the angles?
Yeah. So for example, this is sp2 or trigonal planar structure है, तो इस वजह से इसको ऐसे बनाया हुआ है. ठीक है? Similarly, this one I'm going to call ethanol. Okay, so this is ethanol. So 3 single bonds पे हम usually इसमें bend कर देते हैं उसको to show that this is the kind of bond that you have. So ethanol, propanol, butanol, वो इस तरह से चलते जाएंगे. Similarly, you can have ketones. Now the ketones have basically, so they have to have carbon on both sides. So the smallest ketone that you will have is propanone. You can't have a ketone that's smaller than that. Why? Because you need carbon on both sides of this carbonyl group, which means you can have the smallest one is one with 3 carbons. So उसको ऐसे बना सकते हैं, या अगर आप ऐसे नहीं बनाना तो आप उसको ऐसे भी बना सकते हो. Okay, so इसको हम बोलेंगे propanone, and obviously if I extend the carbon chain, doesn't matter which side, so I can extend it on the right side or the left side, and that will give me different esters. For example, this one is but2-one, okay, because it's the second carbon that has the carbonyl group. Similarly, this one, this is an isomer of this one. We call the left one pent3-one and the right one pent2-one. Now, if I may move this carbonyl to the first carbon, like अगर मैं ये कर दूं, what will its name be?
Pentone or just like pent1.
Pent1-one हो नहीं सकता because you need to have R on both sides of carbon. तो यहाँ पे तो hydrogen है. So this is not ketone anymore. This is aldehyde. So this is pentanol. You can also call it pent1L. Okay. Although होगा ही 1 पे हमेशा, क्योंकि 2 पे जाएगा तो वो ketone बन जाएगा. So pentanol is what we'll call this thing. Achha, what if we have branch? Like if I take that one, pent2-one, और मैं यहाँ पे branch लगा देता हूँ. Now again, you will identify the main chain. So the main chain is this or this, depending on how you choose it. So if this is the main chain, then this is the branch. So we will consider the branch. So we'll say 2-methyl, in fact 4-methyl, because counting starts from the left. So 4-methyl pent2-one. So it follows the same structures as we have seen. Clear? Okay, so I'm going to give you
Sir, how is it 4-methyl pent2-one?
Because if you talk about the number of carbons, then this is 1, 2, 3, 4, 5, and on the 4th one you have a branch. Clear?
But sir, do we start counting from जहाँ से भी like least वो आ रहा हो?
Yeah.
So shouldn't it be 2-methyl
But in that
pent4?
case, we'll have 2-methyl drop 4-one. और प्राइमरी जो आपका मेन फंक्शनल ग्रुप है वो कार्बोनाइल है, तो सबसे छोटा नंबर तो कार्बोनाइल के लिए होना चाहिए. That's the high priority.
ठीक है.
So I'm going to give you a few and I would like you to name them. So okay, name these.
So is the first one 2-methyl pentanol?
That's very good. So 2-methyl Internal. Yep, that's right.
And the second one is a hex tool.
Let's to own. Yeah, that's right.
And then the last one is, so I'm not sure about the last two.
Okay. What about the one on the right? This one.
Uh, so I'm not sure.
इसको open करके बना लो ना, if you are not sure.
Like it on either side of the
Yeah,
CWO.
from either side, this is going to be the fourth carbon with carbonyl, right?
Yeah.
And there's going to be 7 carbons in total.
Gee, sir. So
क्या होगा नाम इसका?
sir, I'm not sure what to call, like after hexone.
Hex के बाद क्या आता है?
Sept.
Sept, exactly. और सेप्ट को और क्या बोलते हैं? सेप्ट हेप्टा भी बोलते हैं. सेप्ट को हेप्ट भी बोलते हैं. Because we can have that as well. Yeah, so there you go. Hept, hept, 4 on. Okay, do the next one. Hello, Mayor.
Hello, sir. Sir, I think I'm going to leave now and then watch the recording because I joined from the other link. So I didn't know the class started.
Okay, that's fine. Okay, so what should be the next one? This is easy, come on.
Sir, the cyclic one.
This, no, not the other one, this one. This is going to be 1, 2, 3, 4, 5, 6. So hex 2
So
on.
ये मैंने बता दिया.
Okay, and the cyclic one is going to be cyclohexanone. Because in a cycle there's no start, it's always going to be the first one. So cyclohexanone बोलते हैं इसको. And this one is carbon that is tertiary carbon. So if you're in a doubt, just open it up, draw it again. So it's called, we have CHO on one side and we have 3 methyl groups. Okay. So that means the long chain is 1, 2, 3. And because the group is CHO, that makes it an aldehyde. So this is going to be propanol. And on the second carbon, we have 2 methyl. Okay, so that one is going to be 2 dimethyl propanol. Okay, that's how we name them. Now let's look at their physical properties. So the physical properties are such that the boiling point of these things, the boiling point of these things is lower than the boiling point of alcohol. So if I notice, then I'm so sorry. Is it stuck? Yeah. So if you look over here, the boiling point of alcohols is higher and boiling point of aldehyde and alkanes is lower, which means aldehyde is somewhere in the middle of alcohols and alkanes. So while alkanes have completely non-polar structure, aldehydes have some pole and alcohols are, again, they have polar structure. So aldehydes have higher boiling point than alkanes. The reason, they're polar, alkanes are non-polar. So there is a permanent dipole. So there is permanent dipole forces, and that is why aldehydes have higher boiling point than alkanes. Now, why do alcohols have higher boiling point than aldehydes? अगर दोनों ही polar हैं और it's all about permanent dipoles, then why do alcohols have higher boiling point than aldehydes? Can you think of a reason?
So hydrogen bonding.
Exactly. Because of hydrogen bonding, that alcohols have oxygen joined to hydrogen. Hydrogen is part of a polar bond, which means they can do hydrogen bonding. So that is stronger than dipole-dipole forces. And that is why they do this. Okay. So alcohols have higher, they have hydrogen bond, aldehydes have permanent dipole, and alkanes have temporary dipole-induced dipoles. Now, can aldehydes make hydrogen bond? That would imply if they did, then they will. Because it
No,
is.
sir.
They can. They can.
They can.
ठीक है? Not with each other. वो एक दूसरे के साथ hydrogen bond नहीं कर सकते. क्योंकि if I have this thing, then there is a slight negative bond here, slight positive bond charge here, and there is lone pairs here and here. So while hydrogen and oxygen are not in a permanent dipole, but water अगर यहाँ पे आता है, so water molecule में जो slight negative, slight positive bonds, dipoles हैं, this can be attracted by the lone pair here. So hydrogen bond यहाँ पर हो सकती है. So this is the hydrogen bond. But that again depends on that how long is this chain that you have. If it becomes too long, then this CHO part becomes a very small part of the thing. So for example, if I have 5 or 6 different carbons, then this is a very small portion of this whole tail, right? Which is why the hydrogen bond won't be that strong. Hydrogen bond टूट जाएगी, strong नहीं बन सकेगी क्योंकि ये chain बहुत लंबी होगी. The tail is too long. Okay, so the dominant force in this case would be the temporary dipoles and slightly permanent dipole on one side. But अगर छोटा molecule है, like up to 4 carbons, then they do dissolve in water, they do form hydrogen bonds. So small aldehydes are soluble because hydrogen bond is a significant part of the intermolecular force. Okay, because H bond is significant compared to total intermolecular forces of attraction, and obviously they can make hydrogen bond with water. Again, they will not make hydrogen bond with each other क्योंकि एक दूसरे के साथ उनको hydrogen नहीं मिलेगा, which is polar. Okay, so that is the physical properties. Number one.
Wait, so why don't they make hydrogen bonds with each other?
I'm sorry.
Why don't they make hydrogen?
What do you need for hydrogen bond to occur? You need hydrogen in a polar bond and lone pair on this other carbon or other atom, right? You have lone pair on oxygen, but you don't have hydrogen in a polar bond in aldehydes, which is why they can make hydrogen bond with water or with alcohols, but not with each other. ठीक है. अब aldehydes बनते कैसे हैं? Aldehydes and ketones are both made by oxidation of alcohols. But how exactly does that happen? So the idea is simple. What you do is you basically you remove 2 hydrogens, and that is what oxidation is. Because remember, oxidation is loss of hydrogen. So you basically do oxidation of alcohols. If it is primary alcohol, it will give you aldehyde. If it is tertiary or secondary alcohol, it will give you ketone. And if it is tertiary alcohol, that can't be oxidized anymore. Okay, so let's see. So if I have, let's suppose, so alcohol में क्या होता है? I have carbon with OH and hydrogen, and on this side I might have this. Now this is a primary alcohol, and this primary alcohol, when I want to oxidize it, I will remove this hydrogen and this hydrogen. Remember this. One hydrogen from oxygen and one from the carbon. That's how you oxidize them. So carbon must provide one hydrogen. When that happens, so now this carbon is bonded with this oxygen and hydrogens are out, which means that this can make a double bond with this oxygen, and that is how you get aldehydes. Usually आप book में देखोगे तो उसने इसको इस तरह से बनाया हुआ है, OH यहाँ top पे लिख दिया था or yeah, but that's fine because it makes it easier to read these things. So you remove these two, and now you have RC with double bond with this oxygen and hydrogen. Okay, now this has to be controlled oxidation. Why controlled? Because if it was allowed to go to completion, aldehydes themselves can be oxidized. Because notice that there is still one hydrogen that this carbon can provide, which means it can further oxidize. तो हमें इनको distillation करनी होती है, ठीक है? We can't just let it oxidize and forget about it कि अच्छा हो जाएगा तो हम बाद में देख लेंगे. We have to distill it off before it gets oxidized further. Okay, so that's important that you need to oxidize, but controlled oxidation, heat, and distill the aldehyde. डिस्टिल नहीं करेंगे, रिफ्लक्स करेंगे तो एल्डिहाइड जो बनेगा वो फर्दर ऑक्सीडाइज हो जाएगा. अच्छा, व्हाट डू वी नीड टू डू दिस? व्हाट रिएजेंट डू वी नीड टू डू दिस? ऑक्सीडाइजिंग एजेंट्स. सो ऑक्सीडेशन एजेंट हमारे सिलेबस में दो हैं जो हमने स्ट्रॉन्ग ऑक्सीडाइजिंग एजेंट्स पढ़े हैं. वन इज K2Cr2O7 acidified. So we write that as H positive, that it has an acid ion. Or we can have KMNO4, again acidified. The color changes are orange to green and purple to colorless, as we know already.
So which do we need controlled oxidation for, primary alcohols or secondary?
Primary alcohols, once they make aldehydes, they can then make carboxylic acid if let them continue. But secondary alcohols, when they do it, when they oxidize, they make ketone. And ketone cannot further oxidize, which is why with ketones we do reflux. So if this is my general formula of ketone, so here R1 hai, R2 hai. So this is my general formula of ketone. So what I'm going to do is I'm going to, sorry, this is my ketone. So यहाँ पर मेरे पास कुछ और like this must be an alcohol. So OH and H, and this is my R2. Now, if I oxidize this one, which means I will add KMNO4 acidified or K2Cr2O7 acidified. And when I do that, this will give me this. And how does that work? You basically remove this H and this OH. That's it. You're removing hydrogen. Again, one hydrogen coming from OH and one from carbon. And because this carbon has an hydrogen to provide, so it easily oxidize हो जाएगा. But tertiary alcohols ये नहीं कर सकते. If I look at tertiary alcohols, then this is the general formula for tertiary alcohol. And you can clearly see why that is the problem. Because while we can remove this hydrogen, दूसरा hydrogen कहाँ से आएगा? है ही नहीं, जिसकी वजह से ये oxidize नहीं होगा. And this one, whenever you're oxidizing, you reflux and you heat it because it makes them react faster. Okay, so you heat and you do it under reflux. Clear so far? अब हमें alcohol से aldehyde बनाना तो आता है, and we know it is oxidation. How would we go back from aldehyde to alcohol?
Reduction.
Reduction. And we have two reducing agents. ठीक है, वो कौन से हैं? One is sodium borohydride, and we are going to use this for A2 as well. तो इसलिए इनको याद कर लो. Sodium borohydride, NaBH4, and the other one is lithium aluminium hydride. Now, sodium borohydride can be aqueous. Okay, so sodium borohydride, you can use it in water. But lithium borohydride, you take that thing and you give it a couple of drops of water, and this will be the last reaction you do in life because it is explosive. So we make sure that we dissolve it in a completely non-polar thing like an ether. Okay? So ethers are useful solvents for this. So this is lithium, aluminium hydride. Okay, so we use this one. If you don't want to do this, then you can do another reduction method, which is what you have studied in O levels as well. You take hydrogen with nickel catalyst. So when you pass hydrogen over this thing using nickel catalyst and you heat it, you basically reduce the thing, because what's reduction? It's adding hydrogen again. तो यहाँ पर वो हो जाता है. Again, why is this possible? हमने तो alkenes में इसको पढ़ा था. We saw that in alkenes you can add hydrogen. So how come this same reaction is allowing us to oxidize this thing? Oh, sorry, reduce this thing. मतलब ये ketone है. How this ketone can be reduced using this method?
So because double bond, so
Exactly.
it's
There's
like
a double bond between carbon and oxygen. Exactly. So just remember that if you have a secondary carbon with carbonyl, if secondary carbonyl hoga to ketone hoga, and if you oxidize, if you reduce it, you will get secondary alcohol, and primary carbonyl, which are aldehydes, if you reduce them, you get alcohols, which are primary alcohols. ठीक है? So let's do a couple of examples और हमें ये इसकी समझ आ जाएगी. So let's suppose I have this thing. Okay, we do lithium aluminium hydride with this in ether. What will we get? So what we'll do is we'll reduce this one and we'll reduce this one. So ये हमने पहले भी क्वेश्चन में देखा हुआ है that you just look at every functional group and identify what that one will do. So इसका आपस में एक दूसरे से ताल्लुक होना जरूरी नहीं है. So this carbonyl, for example, will reduce and give me. So इस सारे को कुछ नहीं होने लगा because these are all non-polar. They're not going to take part in this. So ये सारे का सारा तो I'll just write it as it is. Now this one, I'm going to break the double bond, and remember addition reaction. Addition reaction में क्या होता था? You remove the double bond और वहाँ पे इस पे भी कुछ ऐड कर देते थे, इस पे भी कुछ ऐड कर देते थे. And that's exactly what we are going to do. So we're going to break the double bond with oxygen. We're going to give this a H and this an H. Okay. Now we're going to do the same thing with this one. So we'll take carbon, we'll break that double bond, we'll give this one an H and this one an H, and there you go. So now you have bute. So 3-methyl bute 1,2-diol. That's what you have. Okay. And this one, as you can see, is a primary and secondary alcohol. दोनों हैं इसके अंदर. Okay, let's do another example. Let's suppose I have this thing. Now this again is ketone. Okay, so let's suppose I do a lithium aluminium hydride with this, ether में dissolve किया और heat with reflux किया. ठीक है? Okay, so what happens? Again, I look at this one. मुझे पता है कि ये react करेगा और ये cyclic है, but still alkane है. It won't take part in the reaction, so it will just stay as it is. उसको तो reduce नहीं कर सकते. So this will stay as it is, and this carbon will break down, and I'll get OH here. And obviously the fourth H is there, but मुझे उसको दिखाना नहीं है. Now comes the tricky part. What if I do concentrated H2SO4 with this thing? Now what? अब क्या होगा? मैंने heat भी कर दिया इसको. Now this is going to act as alcohols, and we know alcohols, if you add them into concentrated sulfuric acid, dehydration हो जाती है, elimination reaction होता है. They're going to lose OH and H, and this one can lose OH from here and H from here, and if not that, then OH from here and H from this carbon. So there's दो option है. एक option क्या है? That I will get this whole thing, and this OH is gone, and I have a double bond here. Okay, or the other option is I get this whole thing, sorry, not the ring, and I get a double bond here. So in both cases, I have dehydrated it, and of course, I'll get water as a byproduct. So in fact, both of these are formed based on which carbon is easier to make a carbocation of. So based on that, we can get both of them. उसमें major और minor products होते हैं. Clear? So I'm going to give you
So,
two. Yeah.
ये एक दफा फिर से समझा दूं.
So basically, what we did is simple. As far as aldehydes are concerned, we took this ketone, we reduced it, and when we reduced it, it became secondary alcohol. This double bond broke down. I got OH and carbon with hydrogen. Okay. Now that's an alcohol, and when alcohols undergo elimination or dehydration, they lose OH and H. Now this carbon can lose a OH, but H या इधर से जा सकता है या इधर से जा सकता है. I have two candidates for removing H. So that's what happens. अगर मैं यहाँ से हाइड्रोजन रिमूव करता हूँ तो OH यहाँ से जाएगा, हाइड्रोजन यहाँ से जाएगा, डबल बॉन्ड इन दोनों के बीच में हो जाएंगे. And this one also has an H. ये fourth bond हाइड्रोजन के साथ है. So it can remove OH from here, but H from here, which means that I will get a mixture of this product where the double bond is with this carbon and this product where the double bond is with this carbon. Basically, H कहाँ से remove होता है, उस पे depend करता है कि आपका final product क्या बनेगा. ठीक है?
ठीक है सर.
So I guess that's it for today. आप इसको review करें.
Thank you sir.
And we'll go over oxidation of aldehydes tomorrow. Okay.
Thank you sir.
Yeah,